Hi, I'm Elaine, and welcome to Off-Brand Crash Course. Today we are going to learn basic counting from the resource guide. Do not underestimate it because of its lame name. So the first thing we're going to learn is the multiplication principle. So this is the first form of the multiplication principle. Now the resource guide gives you a definition, but it's really fancy, so I made another one, which is, I hope, a little easier to understand. So the first form is when finding the maximum amount of combos of two groups, multiply the total choices possible for each group. So we see that if you just think about this logically, you have 3 choices for thin crust, then you have 3 choices for regular crust, then you have 3 more choices for thick crust. So when you put it on a graph, it looks like that. You have 3 crusts, 3 toppings, and you multiply the 2 groups, or the amount of choices in each group, which is 2, and you get 9 different pizzas possible. Okay, so this is the second form, which is when finding the maximum amount of combos of any number of objects, multiply the total choices possible for each object. This is just the first form, but now with more groups possible. So if we have 3 different categories with this many possible options, so crust, we have 5 possible options, toppings, 6 possible options, and sizes, we have 5 possible options. So you're going to grab your TI-84 and then multiply it, and you'll see that you have 150 total options of different pizzas you could get with another category. So this is just the same rule as before, but we're adding more. Now this is the final form of the multiplication rule with an actual formula this time. And this rule says when selecting k amount of objects from different groups or when order matters, the number of possibilities is k multiplied by 1 within itself until you get to 1. So that's what you see in this formula here. You have this first number, second number, and then you're going to get all the way down to nk, where nk is a number of ways to select the kth object. So it's confusing, but we'll put it to a practice problem. So you have 8 runners who are racing in a 200-meter dash. In how many different sequences could the runners finish the race? So we're trying to select different sequences, and we have 8 runners. So if you finish first, you can't go back and then finish second as well. So this is when you see that you can only be one option in the sequence. So after the first person finishes, there's going to be 7 people left to compete. Then after the second person finishes, there's going to be 6. So you just keep going down all the way until you get to the last person who finished last. And that's the amount of different sequences that you could have, because think about it logically, once you finish, you're not going to go back and then finish again. So you always have one less person after the new person finishes. So you put this in your calculator and you solve it, and you get 40,320 sequences. Is that the answer? Yes, it is. Okay, this is the second thing we're going to learn, permutations and combinations. So permutation is the selection of objects from a group where no object is allowed to be selected more than once and the order of selection matters. That is the important part to remember. Permutation is when order matters. Combination is the selection of objects from a group where no object is allowed to be selected more than once and the order of selection does not matter. So this is important. Permutation, order matters. Combination, order doesn't matter. There's one thing you take notes on. It's that. Okay, now for factorials. Factorials are symbolized as an exclamation mark, and it means to multiply every whole number from the number indicated down to 1. The factorial symbol is written after the number. So you have 3 factorial and some factorial. Looks like that. So it looks like what we just did with the runners, but now there's an official fancy name. And you go all the way down to 1 each time. So if you have a kid flip an alphabet puzzle on the floor, if she picks them up blindly and places them in a line, how many possible arrangements of the letters are there? Is it permutation or combination? So let's start with that first. Does the order matter in this situation or does it not? Let's think about this. If you have, say, you put the letter A down and arrange it, then you put the letter D down. Now compare that to if you put the letter D down first and the letter A down afterwards. Those are 2 different arrangements. Even though it's the same 2 letters in the line, there are 2 different arrangements because of the order that they went in. So because order matters, this is a permutation. Now, how many possible arrangements are there? There's 26 letters in an alphabet. And every time you put one down, you have one less possible letter to put down. So it's going to be like before 26 and 24, dot, dot, dot. Or now we can say it's 26 factorial. Now, when you put it in a calculator, instead of having to multiply all these numbers starting from 26, what you can do is put 26 in your calculator, then press math on a TI-84, and then go all the way across to probability. And then you'll see that the fourth option is factorial. So you just go down to that. And then now you have 26 factorial on your calculator. The answer is a gigantic number about this much. Did we get it right? We did. Permutation, and then that gigantic number is what we just did. So now this is the formula for permutation and combination. So permutation formula is the number of ways to select k objects out of a group of n objects. In a permutation, so this is where order matters, and it is given by this formula. Combination is the number of ways to select k objects out of a group of n objects in a combination. So order does not matter and is given by this formula. So you probably also want to write this down. I will wait 3 seconds while you do it. Okay. So now we have 2 practice problems. Read these quickly and think, is this a permutation question or is this a combination question? I will allow you another 3 seconds to think. Okay, time is up. So the first question, you see the math club has 40 members. How many ways can a president and a vice president be selected for the team? Here, order does matter because you may have the same 2 people selected for office, but one is going to be president and one is going to be vice president. And then if you switch the order and the other person is president and vice, okay, so let's just say that there's 2 people. Carl is president. And then the other person is Lisa, and she's VP. So if you switch the 2, where Lisa is pres and then Carl is VP, that is a different combination for office and math club. So even though it's the same 2 people, you chose different things you chose different people for the office position or the position in office. So here the order does matter. Now for this question over here, 5 of 40 members in math club are being selected to compete. How many different ways can a team be made? Does order matter here or does it not? The answer is order does not matter because the 5 people that you select for the team, it doesn't matter what order that you put them in a team. They're all just going to be team A. So even if I put like Lisa, Carl, David, Matthew, and Pete in a team, it doesn't matter what order that I put them in first or last, there's still going to be one combination. And if I change the order, it's still the same combination. So this is a combination, and this is a permutation. So now we're going to try and solve these with the equation. So remember that n is the total amount that you have. So n is 40 here, and we're looking for 2 positions, so k would be 2. So that looks like which is simplified to 40 factorial over 38 factorial. And when you plug that into a calculator, you get 1,560 different ways to select it. So that is what you get. Now, for a combination, we also still have 40 total members, but now we're looking for 5 people. And because it's a combination, we're going to have a different formula. Oops, I think I put this in wrong. I did. Roar. Okay, hold on. So n is 40 and then k is 5. So that looks like that. So this one, we're going to actually try and put in our calculator. You can attempt to do this and race me, but I think I'm going to beat you. Actually, maybe you'll beat me, because this is quite hard to do under pressure. Okay. All right, I got the answer. That is the answer. Hopefully I beat you. I mean, I'm too competitive. Hopefully we tied. So this is the total amount of ways to select a team for Math Club. You'll see that there are way more than permutation. Okay, that concludes my presentation. Thank you for listening like the good online student I know you are. You better have been focusing this whole time. And thank you for listening.